Hi, welcome to 10.2. It is Saturday afternoon. I've got to get this done and then go to some soccer games, and then it's all good. So our learning targets, I can use angle measures to find arc measures. Another word for this is arc length. And I can describe arcs made by different structures. All right, here we go. So let's start off. I can find x and y. Just a little bit of review here. There's a reason why, but notice that these two are a linear pair. Linear pairs are supplementary. Supplementary means they add up to 180. So x plus 120 is equal to 180. Subtract 120, x is equal to 60. Also, we know that this is x also because they're vertical angles. And then we know that this is x because they're alternate interior angles. And then this will be the same. So that's also the same for y. Okay? Why is this not that dark? Let's see. I wonder if I use a Sharpie. Do I have a black Sharpie? Nope, I don't have a black Sharpie, so I guess I can't use it. Any case, continue. Now, look at here. These two are the same angle. That means they're going to equal the exact same thing. And all four of these angles will add up to equal 180. So I'm going to take 180 and subtract, maybe put this in black, subtract the 70 and 40. That's going to equal 70 degrees. So I know that x plus y is equal to 70 degrees, and these have to be the same. So you can write this as 2x is equal to 70. So x is equal to 35 degrees, which is the same as y. All right? Okay, so here's our information. Measuring arcs. The measure of a minor arc is the measure of its central angle. Okay, so this is actually kind of hard to see. I know I don't have this even in color, which I'm kind of bummed about. This is my extra copy, and I thought it was going to be in color. So this is a central angle. A central angle, the vertex is at the center of a circle, and this will be the arc length. So if this is 60 degrees, this will be 60 degrees. That's for central angles. Later on, we'll have angles that start on the circle and go to the opposite side, and it'll be different. So the measure, this is also called the measure of arc AB, and notice the notation here. It's hard to read. Measure of AB, and they put an arc here. So try not to make that look like a straight angle. That's going to be the same as the measure of angle ACB. And in this case, it's equal to 60 degrees. Okay? Now, measure of A, they have D right here, ADB. This will be the major arc, DB. Okay, it'll be 360 minus 60, which is 300 degrees. All right, so major arc is usually a smaller angle. Sorry, major arc is the bigger angle, minor arc is the smaller angle. All right, let's find the measure of each arc of circle O, where CB is the diameter. Okay, so arc AB, right here. If this is 60, this will be 60. Mark ACB. ACB will be 360 minus the 60, which is equal to 300. And how about mark BAC? Okay, well, we know that this is the diameter, so this is going to be half the circle. That'll be 180 degrees. So far, so good? Hard to see. I'm not sure what to do about that. Okay. Next page. Adjacent. You know what adjacent means next to. Adjacent arcs. Two arcs of the same circle are adjacent if they have a common endpoint. Okay? You can add the measures of two adjacent arcs. Two circles are congruent circles if they have the same radius. I showed you that in the picture on first section. Two arcs are congruent arcs if they have the same measure and they are arcs of the same circle or of different circles. Okay, so they just have to have the same measure. If circle C is congruent to circle D, then you can write this. Okay, there's your congruent statement. Here we go. That was important for arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two adjacent arcs. All right, so for instance, this arc right here, let's do it in red. And this arc right here, we'll do it in green, is equal to the whole arc. So there's your arc addition postulate, okay? And normally they will have it, you have a center. Okay, so this angle plus this angle will equal the whole thing, or this arc plus that arc equals that whole arc. All right, so let's look at that. Example 2. The result of a survey about students' favorite sports is shown in pie graph. Find the indicated arcs. Okay. Now there's a little thing that we have to okay, not too bad. Measure of arc, I actually had to label these, A, B, C, D, and E. So measure of arc AC would be these two together. So AC, we take 36 plus 40, 76 degrees. All right, BCE, we take 40, B plus 60 plus 80. That's 180 degrees. And if you look, that looks like a diameter, doesn't it? Okay, DEA. So DEA would be the 80 plus 144 is 224. And then EBA. If it's EBA, we can't go that way. EBA. So this is going to be 180 plus 36. $216. Okay, not too hard. Now there's one little thing that I want to show you. Kind of like, let's apply this. Do you agree that a full circle is 360? And we have a total of 400 students. If we know that this is 36 degrees, we can find out what percentage that is of the circle. So for instance, squash players. I really don't even know what that is. Okay, so we have 36 degrees. 36 degrees, and if I divide by 360, I will get the percentage of the circle. Well, remember, there are 450 kids total, so if I take that percentage times 450, it'll tell me how many students play squash. It'll be 45 students. The percent of 450, so of means times. So how about tennis? We have 40 degrees. So 40 degrees of 360 will give us the percentage of students that will play tennis. And we have a total of 450 students. So when you multiply them, you're going to get 50. How about hockey? There's a lot of hockey players here, so it must be a Minnesota school. I don't know. Pretty much hockey is pretty popular. All right, so this is 60 out of 360. Multiply it by 450. We're going to get 75. Netball, whatever that is. Why is that so popular? Okay, so netball we have 80 out of 360 times 450 is going to equal 100. And last but not least, football. There's no soccer or baseball. Basketball. I wonder what place where this is at. It's got to be in a foreign country. Well, not many form. Maybe this is their soccer. That's going to be 180 students, not degrees, okay? All right, last page. I told you this would be a fast video. Actually, I didn't tell you that, but it is a fast video. And we're still recording, so that's a good thing. All right, tell whether the given arcs are congruent or not. So AD, which is this whole thing, and BD. Oh, sorry, AC and BD. Well, they both have the central angle. So yes, that's the same circle. They can be different circles, but they have the same central angle, same radius, so they've got to have the same arcs. How about MN, which is this in red, and OP, which is this in green? No, the distances are going to be different. The arcs are going to be different. They have the same central angle, but they have different radii. Okay, so no, the radii are different. They're congruent here, okay? All those radii are congruent over in the first circle. All right, how about AB, which is this angle, and that's 42 degrees, and CD. Well, we have to find out what this is. So if I take 360 minus the 180 plus 42 plus 96, I should get 42 degrees. So this is 42. Hey, those are going to be congruent arcs. So yes. This is our homework. And there's our Common Core Standard. Have a nice day.